So this video today is from sheet 111. This is the last sheet that I'm going to have you guys do, and we're going to do some more combination circuits, but notice this time we're mixing it up. The last sheet we did was just total resistance, but now we're going to solve for a current value, and notice again we're using the different units. So we're going to go to milliamps is the unit of measure we would like the current measured in. We have up here a 2K resistor, we have a 2.5K resistor, and we have a 10K resistor. So what I've done in order to help you is kind of get you started here is I did some math up here at the top. Notice what I did. I took R1, which was 2K, and I multiplied 2 times 1,000, and that gives me 2,000 ohms is my resistance value for R1. I did the same thing for R2, so took 2.5K, multiplied that by 1,000, and we get 2,500 ohms for resistor 2. And the same procedure for resistor 3. We converted the 10K to the 10,000 ohms by multiplying 10 times 1,000 gives us 10,000 ohms. Then we know what our voltage total is right here. It tells us it's 1,000 volts. So we just use our three simple letters of E, I, and R. And notice down here I set the problem up for you. E, which is 1,000 volts, I'm going to divide that by my resistance total, and that is going to equal my current total. Now a couple notes here. In order to get resistance total, so we want to solve to get this first, notice what we have to do. We've got two resistor values right here. They're in parallel with each other. We're going to have to solve those first. Once we have that solved, then we literally can draw a brand new circuit, and we'll have two resistors in series with one another. So this will be a 1,000 volt source. This one's still going to be 2,000 ohms up here, but you have to determine what that resistor value is right there by solving this one and this one in parallel with each other. So here's the second one from that sheet. This is problem number 6. Again, mixing it up a little bit, now we're going to solve for the voltage total. So I've got the formula we're going to use down here. Again, we're using our three little letters, E, I, R. So we're solving for E, so that's what we're trying to figure out. We know what I is. I is this current value down here. Notice they gave it to us again in milliamps, so we had to do a conversion. So I converted. I took the 10 and I divided it this time because we're going up to our base unit. So I divided that by 1,000. That gives me my 0.01 amps down here. And we still need to find our resistance total, so that's kind of our first step. So again, we had to do some conversion on those resistors as well. We converted the first one to 15,000 ohms. Resistor 2 we converted to 5,000 ohms. Resistor 3 is just 250 ohms, and number 4 is 1,000 ohms. So again, in an interest of trying to find resistance total, we're going to have to first focus on this little parallel section here first. Our goal is to try to eliminate that, so that once we have that kind of squished together, then we just simply have these three resistors now, and those are all in series with each other. So 250, and then of course this one is our question mark because that is solved from these two right here in parallel. So that's going to be your starting point. And once you have that solved, then you have your resistance total, you'll have your current total, And so then you should be able to determine what your total voltage is.